Today, let's learn circles, which is chapter 9 of CBSE syllabus mathematics. Now, let's understand what is circle. Uh, One of the definition is, look at the second point. Circle is a round shape. Look at the shape here. It's a round shape with no corners and no edges. Okay, it has no corners, it has no edges, it has no opening. It's a closed shape with no corners or edges. That's one definition. Let's go for other definition. A circle is a closed. Now it's a closed. Look at it here. It's no openings here. It's a closed and two-dimensional shape. So look at, there's no depth here, right? You can see uh, two dimensions, not the depth here, right? So a circle is a closed two-dimensional shape. Okay, formed. How it is formed? Formed by all the points in a plane. See, the entire thing is a plane here. Okay, look at the whole thing is a plane here, and we let's assume for a moment, we have you can draw innumerable number of points across your plane. Okay, anywhere. Okay, let's take innumerable number of points. Now, I can draw innumerable number of points on a plane. Let's take a subset of these points, okay, which are equal distance from the center point. Okay, which are equal distance. Let's measure a distance from this point and mark all the points in the plane. Okay, so now join all these points which are equidistant from the center. That makes a circle. Okay, that's one of the definition. Now let's go proper definition way. A circle is a closed shape and it's a two-dimensional shape. It's a closed shape and two-dimensional shape. A circle is a closed and two-dimensional shape formed by all the points in a plane that are equidistant. That's the important point here. That are equidistant from a given point, which is center. Okay, this is one of the definitions in a circle. And there are a couple of parts of circle which we'll study in the upcoming slides. But let's understand why circle is important. Circles are one of the most basic shapes. Circle is one of the most basic shapes in geometry and are an important part of mathematics and have many applications in the real world. Take the technology world, take the real world. It has n number of applications, and we must master this or understand center. I mean circle and all aspects of circle to a greater depth. And the goal of this chapter video is to understand circle and get deep into it. Okay, let's take a quick quiz now. Left side, as you see, the circle. Um, I have marked three line segments. One is A here, this one, and B here, this one, and C here. Now the quiz is which of these segments A, B, and C, which of these segments in the circle below is a radius? Each of these segments, okay, A, B, or C. Uh, let's go for an answer. So the answer here is A and B. See why it connects. The A is the line which is drawn from the center of the circle to the edge of the circle, or say circumference. Okay, circle. So that gives you A, and of course B is also very similar, right? It drawn from center of the circle to the circumference, touching the circumference. So A and B are the radii. Okay. C is of course not a radius. Let's talk about it later. Let's get into the next topic, chord. See, as I told earlier, the circle has many parts. One of that is chord. Okay, so look at the image here, which is circle. See the center of it, and A and B, the line blue colored one. I draw a line from A to B. Remember, A is a point on the circle or circumference. B is the point on the circle or circumference, right? So now if I draw a join 2 points on the circumference of circle and that line segment we can call it as a chord. Okay, so coming back to the actual definition here, if you see here, a chord is a line segment. Okay, the segment means it's a full line and take a portion of it. So from this here, a segment of the line. Okay, the a chord is a line segment that connects two points on a circle. Okay, these are the 2 points on a circle. I can draw it one more point from here to here. This can be it's a straight line. Okay, it can be a circle. Okay, the chord is a line segment that connects 2 points on a circle. Okay, one more important interesting property of this chord is, okay, we have a the AB as a chord. I will draw, okay, a perpendicular. I will draw a perpendicular from the center, from to this arc. I'll draw a perpendicular line, which is of course 90-degree perpendicular, right? I'll draw a line which is perpendicular to this chord and connecting to the center of it. Okay, and so a circle to a chord, but and the perpendicular from the center of the circle to a chord bisects the chord. Bi means two, sec means section, the portion of it, right? So what it will do is the chord is split into two parts or bisected, okay, by this perpendicular line CG. Okay, this is a line perpendicular to AB from C, from the center. So this will bisect the chord. This is one of the interesting property of the chord. Okay, right. Hmm. Let's come back to the quiz now. You can see the diagram here. Just I placed some circle diagram with some fancy words or parts of it, say, on the diagram, so that you can get a clue out of it and answer my quiz question. Okay. Okay, now tell me, what is the longest chord in the circle? We understood what is circle. Sorry, what is chord we understood. Chord is a line segment which connects the 2 points on the circumference of the circle. Okay, now tell me, which is the longest chord in the circle? Okay, is it the radius? Is it this one? Is it this one? Or let's go for an answer now. Uh, the answer is diameter of the circle. Now question is, what is diameter? We'll come to it later. But what is diameter here is the it's a line segment again, which is passing through the center of the circle. Remember, diameter is also a line segment. Remember, diameter is also a chord. Only difference is the diameter always passes through the center. Okay, from this point, to this point, but passes through the center of it. Understand? And diameter is the longest chord. Okay, let's go for one more. uh, okay, let's go for one more quiz. Again, I place a couple of diagrams so that you derive or you get some clues out of it and answer our questions. Okay. Okay, then tell me now, what are the parts associated with a circle? Till now, I was talking about chord and I was talking about that's all, chord and radius. That's all, right? Let's talk about some other parts of the circle. What are those? You can name some of them, but I'm going for continuation. Okay, okay. First one is center. Okay, what is this center is? As you can see here, hmm, as you can see here, the whole thing is a circle, and we have a center here. Here we have center here. Here we have a center here. Here we have a center here. Right. So center is a point. It has no dimensions. It's just a point, right? No dimensions. It's a fixed point. It doesn't move, and it is all the points on the circumference are at equal distance from this reference, which is a center or point, right? So we call this a center. If it's a fixed point in the middle of the circle, it means all the points are equal distance. All these points are at equal distance. All these points are at equal distance from this. This is equal to this is equal to this. Okay, that's a one important part of the circle. Let's go for other part of the circle. It's the radius now. What is radius? It's a distance. It's a distance from the center. It's a distance from the center to any point on the circle. On the circle means we always think circumference is a circle. Okay, it's a distance from the center to any point on the circle. Okay, let's take this is a center. I'll take this point as a reference, and this distance is circle. Let me take one more point. So this distance is a radius. Sorry. Okay, this is a radius. This is a radius. I'll take one more point here on the circumference. This is the radius of it. Okay, it's a distance from the center to any point on the circumference. That's the radius. Okay, let's go for one more point. It's a diameter. One more part. It's again the distance across the circle. Across the circle means from this point to this point across the circle, edge to edge, end to end, or edge to edge, extreme ends, right? It's a distance across the circle that passes through the center. Okay, so but look at it. This is a point. This is a point. It will not pass like this. It will pass through the center. Okay, so it takes a point. This is a point. Okay, across the edges. These are across edges, the across the mm, you know the circle, and I'll connect them, but line passes through this center, and I call it as a diameter. Okay, it's a distance across the circle through its center. Okay, okay, next go for one more word which we already seen it. Chord is again, as I mentioned you, radius is a line segment but center to the circumference. Diameter is a line segment, but it's end to end of the circle passing through the center. Similarly, we have one more line segment which is chord. How it is defined is it connects 2 points on a circle. Okay, you take a circle, for example, this is one point and this is one point, and it connects it. It's a chord. And I can take this point and this point. It's a chord. Okay, it's a line segment that connects 2 points on the circumference or on the circle. Chord. Okay, let's go for one more thing. Arc is, think of it like a bent curve like that. It's a bent arc. Okay, arc, it's a portion of a circle circumference. The whole thing is a circumference, and you take a portion of it. It is a arc. For example, here look at this diagram. Here look at this diagram. I'm making a chord here. The arc, this is a circumference. Whole thing is a circumference. Remember, if I take a portion of the circumference from this point all the way from here, I call this as an arc. Okay, and we have a minor arc. We have a major arc. Okay, for example, in this case, red colored one is a minor arc. This green colored is a major arc because it's a bigger circle, bigger portion of the circumference. Okay, here if you see, it's an arc, and the remaining is also major arc. It's a minor arc. Okay, similarly, we can go for it, right? Think of it. Next, okay, let's go for segment now. With one more portion of the the circle. What is this? It is a section of a circle. Okay, enclosed by an arc at one side and chord at other side. Okay, look at this diagram here. For example, this yellow color you see this. Okay, I mentioned you this left portion is a arc, this right portion is a chord. Now what I'm trying to say is this segment is the section of the circle, okay, which is enclosed by one side arc, the other side chord. That's how we can define it. A section of a circle enclosed by an arc. An arc means one arc and one chord. An arc and a chord. This is the definition of segment. And again, we have a major segment and minor segment. If the area, or portion of this segment is smaller compared to the rest of the segments, I call it the minor segment. If this portion is bigger than the other segment, I call it the major segment. Okay. Again, we have a sector also. What is sector? It's again a region. Again, it is a section of a circle, or a region of a circle, or a part of a circle. Okay, it is a region of a circle enclosed again by radii, two radii. It means two radius. Okay, two radii and again an arc. Look at this diagram here, this portion. So this is from the center. From here to here is a, okay. From here to here is a radius. From here to here is a radius. There are two radiuses now, two radii, and this is an arc. So now this what, how can we define this sector is, this sector is a region of a circle enclosed by two radii, this and this, two radii and arc. Okay. Then let's go for understand what is tangent. See, again a tangent. Tangent is again a line. Okay, that touches the circle at exactly at one point. Look at this circle now. Look at this circle now. I'm drawing a line here. It's a line. So tangent is a line, remember. Okay, tangent is a line, but it is touching a circle at exactly one point. Okay, so that I call it as a tangent. Similarly, look at this diagram also. Look at this line segment or line of it. So line is not going inside, not going away from it. It is just touching and passing on at one point, at exactly at one point. That's a tangent. Okay, you can clearly see this diagram here. Let's understand what is secant now. Secant is again a line, but that intersects the circle. Okay, at 2 points. See, tangent does it at one point and it touches. Okay, and it doesn't intersect, it touches. So secant is a line that intersects. It means it passes through the circle at 2 points. Look at this line here. This is a straight line. It touches, intersects the circle at one point here and here again. So it means this is a secant. This line is secant. So similarly, look at this. This color is a secant. Touches the circle, crosses the circle here, intersects the circle here. Okay. So it's a secant. Okay. Yeah. These are the. Let's go for subtended angles now. It's an important concept again. One more. Okay. Look at the diagrams. I just placed it. We'll come to it later. Okay. What is this subtended angle? Remember, there are two words: sub, tend, and angle. Okay. Let's go slowly. Okay, first of all, let's understand what is this subtended angle means. It's an angle. Subtended angle is an angle. Okay, within a circle. So this whole thing is a circle. This whole thing is a circle. And what I'm trying to say is this is an angle within a circle. Okay, inside the circle, but it is created by two chords. Okay, and what are those two chords? Those two chords are meeting at a point. But meeting at a point, what, inside the circle or outside the circle or on the circle? On the circle or on the circumference. So let's take this example. A and B are, because see, B is a point on the circumference, A is a point on the circumference. Okay, and of course C is also a point on the circle or circumference. Now let me join AB. So now AB is a chord. Okay, and of course CB also chord. There are two chords now. And this AB and CB, which are two chords, are meeting at a point B, and at a point B on the, which is on the circumference of the circle. Remember, now because they are meeting at a point, and it is they are forming a angle, which let's call it as theta. Okay, and this angle we call it as a subtended angle. Okay, similarly in this example also. Okay, so look at it. Diagrams show that inscribed angle. It's inscribed angle. Okay, subtended by, this angle theta is subtended by arc AC. This arc AC. Okay, this arc AC. Okay, from point B, from point B for two. I mean this circle and this circle. Okay, how do you say this? Okay, how do you say that? It's an inscribed angle. Theta is an inscribed angle. Theta is inscribed angle subtended by this arc. AC is an arc, remember. Okay, arc from B. Okay, summary. That's all the definition. Similarly here, Okay, theta is an angle subtended by this arc AC. Okay, from the point B. That's all the definition of subtended angle. Let's go for a more deeper definition in the next slide. Okay, let's go a little bit deeper here. Yeah, what is the word meaning sub here? See, sub is a prefix, you know. The meaning is under or beneath. It gives a couple of it takes a couple of other meanings also. Let's take under and or beneath meaning here. Sub means. There is one more word which is a verb, you know. This sub is a prefix, and there's one more word, tendir, which is again a verb here, meaning to stretch, to extend, or to aim. Let's go for this extend, definition of sub. Okay, this is how the word subtended, word is derived or formed. Okay, okay. Now look at the diagram here. Okay, so now let's take a line segment here. Uh, let's take a line segment here, PQ. So P and Q. Let's take a line segment here from P. Okay, and let's take one more point here, R. So just take a point here, R. Okay, of course, remember this point R should not be on the line P and Q. Should not be on the P. Okay, then let's join PR and QR. Let's join PR, this P to PR and QR. Let's join them. Now it becomes circle. I mean, it looks like a triangle. Let's okay later see it. Now join PR and QR. Okay, this see the like at the diagram. Okay. Okay. All right. So now we joined. I took a point R, which is outside the line PQ. I joined them. I joined them. Okay. Now then it forms an angle now. Look at it. R angle PRQ. This angle. Let me call it as theta or symbol PRQ. The angle PRQ is called the angle. Of course, it's an angle, but its angle subtended by this line segment PQ. Okay, this angle subtended by the line segment PQ at the point R. This is how the def we call when we say now onwards when we refer subtended angle. When I say PRQ is a subtended angle, it means it's an angle subtended by the line PQ at the point R. That's how the definition is. Okay, we now just imagine the same, the PQ line inside the diagram. Now PQ becomes a card. Okay, so the PQ, earlier it was, I used to refer the PQ as just a line. Now I can refer to it as a card because it's a line segment, but connecting the 2 points on the circumference. I call it as a card. Now let's again take one more point, which is of course not on the PQ, or let's assume for a moment it's also, or is also a point taken on the circumference of the circle. Now, by previous definition, I can say that within the circle, the angle, this angle, okay, PRQ is subtended by the chord PQ at the point R. That's how we define. Similarly, it also has the line, the PQ. Look at this angle also. The angle PSQ is again a subtended angle. Okay, which is subtended by the line or by the chord PQ at the point S. That's what we can talk about. That's what we can mention about subtended angles in this. Okay, now let's try to understand how we use the word subtended angle in our day-to-day usage or while learning next topics, right? Let's do this way. Look at this triangle, which it's not a triangle, it's a triangle, but it's a line PQ, and we joined R. We took a point R, which is outside the line PQ, and I joined RP and I joined RQ. Now we can see angle R, which is PRQ. I can call this line angle PRQ as an angle subtended by angle R. This angle R subtended by line PQ. Okay, now let's go to one level up next, and we place this triangle, fine. These points R and PQ line segments within the circle. Okay, and that's how the circle. Okay, again the line PQ is now becomes a segment. Of course, line segment it now becomes a card. Okay, and now we have line point R on the circumference, point S on the circumference, and we have one more point which is O, which is the center of the circle, right? So now look at my question now is what are these angles POQ? Is POQ, and what are these angle PRQ and PSQ? PRQ and PSQ. How are this angle? How are we going to refer to these angles in our usage? Okay. Now how are we use it? Let's understand that part, right? Look at the word angle POQ. This angle POQ is a angle subtended by the chord PQ at the center. Angle POQ is a angle subtended by the chord PQ at the center, means O. Similarly, angle R or angle PRQ is an angle subtended by the line PQ at the place R. And similarly, we can say that angle PSQ is an angle. Okay, it's an angle subtended by the chord PQ at the point S, which is of course on the circumference of the circle. That's how typical usage of these subtended angles. Okay. Now let us take a couple of questions on the topics that we studied till now. Okay. Okay, let's go for the first topic. Then what is the relationship? I was talking about chord, I was talking about angle, right? Let's connect them both together, right? So what is the relationship between the size of the chord, or say length of the chord, and the angle subtended by it at the center? See, we're talking about center, remember. Let's understand what is the relationship. Okay, it's a question. Now, can someone answer it? I'm giving a clue here. Okay, this is a circle. Okay, and I have drawn cards. I've done the cards of multiple length. So we have a smaller card, bigger card, longer card, and longest card, which of course which is a diameter now. Okay, now tell me which is the which which card forms the largest, or the bigger angle at the center. Remember, at the center. Okay, so let me go to the next topic, next answer for it. Look at it. I'm going to draw a diagram here now. See, look at it. This is a card. I made an angle here like this. It made some angle. Now I draw a longer card now here. I'll draw it like this. Okay, so let me take one more diagram, green color. Okay, so now look at this. This is quite a bigger one compared to the previous one. I'll draw a one more subtended angle from this longer card. Now this angle becomes wider. Okay, if with wider. So what is the takeaway now here is longer the card. Okay, longer the card, bigger is the angle subtended by that card at the center. That's the takeaway from here. Okay, longer the card, bigger the angle subtended by it at the center. Now you should do the similar exercise. What is the relationship between the length of the card and the angle subtended by it at a point on the circle? You should find the next answer for it. Okay, let's go to the next topic. Okay, one more quiz now, right? Um, okay, okay. What is the question now? What will happen if you take two equal cards? Okay, last topic, last slide, we are talking about the cards of different length and angles subtended, right? Now let's take two cards which are of equal length. Okay, what will happen if you take two equal cards of a circle? Will the angle subtended by at the center be the same or not? Is the question now. I'm giving a clue now. I give a diagram. So this is one. This is a this line is DC is a one card and AB is the other card. Of course, what I'm trying to mention is I'm giving it you. What is the assumption now is AB is equal to CD. Okay, now cards are equal. Now look at this angle. Angle angle this one. Okay, angle DOC or COD. Angle COD is angle subtended by DC at O, center, right? Similarly, angle AOB is an angle subtended by the chord AB at center. Now, what is given to you is AB is equal to CD. Now, tell me what is the relationship between, say, this angle and this angle? Okay, what is that question? Let's go for an answer now. Okay, answer. What is the answer now? Answer. Look at the diagram. If you take two equal chords of a circle, okay, two equal is AB and CD angle, the angle subtended at the center will be same. That's what is the takeaway. Angle, this angle is equal to this angle. Okay, this angle is equal to this angle. Angle subtended by them will be same. That's a question. Let's go. We're talking about two cards, right? Let's take an example of more than two cards. Like in this example, three cards which are equal, remember. So then what is the learning from here is, because AB and CD and EF are which are the cards, three cards which are equal in size, the conclusion now is the angle subtended by all three cards will be equal. Remember, angle has to be subtended at center. Okay, it's a takeaway. Some pictorial diagram. Look at this. AB, the AB, ML, and PQ are say 4.21 say units. Okay, centimeters. Call it as, and O is the center of it. Now, what is observation now? What is the observation now is, the arcs are also same. Interesting. Same chord length, same arc length. Okay, that's interesting stuff, right? One more interesting stuff is angles are also same. This angle is equal to this angle is equal to this angle. Okay, let's go for, okay, let's talk about theorems in the next class. Let's stop it here.